Our next step is to look at the effects of changing dimensions. This means what happens to the area when you change one or both dimensions of a figure. First thing we are asked to do is look at rectangle A and calculate the area. Well, we note that rectangle A is 5 square down, and it's 2 squares across the top, or wide. So we would say 5 times 2 is 10, and in this case they didn't give us units, so we would say units squared. This is an example of why when we do area it's talking squares on the units, because we want to know how many squares are covered by that shape. So we find out that rectangle A is 10 square units, or 10 units squared. We're then asked to use the grid to the right and draw a new rectangle in which one of the dimensions, specifically the height, has been doubled. In other words, the height will be 10 centimeters instead of 5, but the width is still going to be 2. And we are asked to label this as rectangle D. Now we are asked to calculate the area for this rectangle. So we note that it is 10 centimeters high times, we now know that the unit's 2 centimeters wide, and that equals 20 centimeters squared. Our next thing we're asked to do is to compare the two areas. So if we look, when one of the dimensions was doubled, 2 times as big, meaning the 5 went to 10, what happened to the area? The area also doubled and is 2 times as big, because the area went from 10 centimeters squared to 20 centimeters squared. Now, what happens if the height remained 5 and doubled the other dimension, the base? So what we're saying is the base would now be 4 and the height would be 5. And we would label this rectangle E. So what would the area for that rectangle be? We know that it's 5 centimeters high, 4 centimeters wide, and we get 20 centimeters squared. We're asked to compare this to the original area, meaning rectangle A, and we should note that it's 2 times as big. So we doubled one dimension, didn't matter which one. In either case, our area was twice as big and doubled. Now moving on, we're asked to use the grid to the right to draw a new rectangle in which we double both dimensions, the height and the base. Therefore, the height is 10 and the base is 4. And we are asked to label this rectangle F. And we're asked to calculate the area of rectangle F. Well, 10 times 4 would be 40 centimeters squared, because we have 40 squares that measure 1 centimeter on each side that are covering that entire rectangle. And we're asked how that compares. Well, the original one was 10, this one's 40. It's 4 times as big. When we doubled both dimensions, doubled the length, meaning we took the length and we multiplied by 2, and we doubled the width, meaning we multiplied it by 2. When we doubled both of them, we ended up getting an area that was 4 times as big as the original. Now let's see what happens with the triangle. We're asked to calculate the area of triangle B. We should note that it measures 3 centimeters across the bottom, and that it measures 4 centimeters up and down, the height. And since it's a triangle and a triangle is half of a rectangle, we have to divide by 2. And we end up with 6 centimeters squared for the area of the triangle. So we're asked to consider similar scenarios as what happened with the rectangles. What would the area be if one of the dimensions is tripled? So the base becomes 9, the height remains 4. We still have to divide by 2 because it's still a triangle, and we get 18 centimeters squared. So how does the original compare to the new? What it's asking is, how does the new compare to the original? That's our new one. The original, well, 18 over 6 is 3, so we end up with 3 times as big. Now we're asked what would happen if we tripled the other dimension, meaning the height of the triangle is 12. Instead of 4, the base remains at 3. We know we still are going to have to divide by 2 because it's a triangle, and we end up with 18 centimeters squared as our area. So when we compare the new area to the original area, we get that it's 3 times as big. Moving on to the next one, we're asked what would the area of the triangle be if one dimension is doubled and the other is tripled. The base would be 9, that's what's tripled, and the height would be 8, that's the one that's doubled. We know we have to divide by 2 because it's a triangle, and we get 36 centimeters squared for the area. So how does the new area of 36 centimeters squared compared to the original area of 6 centimeters squared? And we get that it's 6 times as big. Hopefully by this point, and seeing what's happened with the triangles and rectangles, you're now able to take this and apply it to any situation with any polygon, meaning any figure made up entirely of straight sides. Now let's answer some questions just to review what we've done with rectangles and triangles. So when we doubled one dimension, what happened to the area? Well, if you take a look back at what happened to rectangle A and triangle B when one dimension was doubled, specifically rectangle A, you should note that when we doubled one, that means it's 2 times bigger. The area became 2 times bigger. And with the triangles, when we tripled one dimension, meaning we multiplied it by 3, it became 3 times bigger. And so what do you think would happen to the area if one of the dimensions was quadrupled, meaning we multiplied one of the sides by 4? Well, the answer is the area would be 4 times bigger. And what do you think would happen if to the area of the figure if one of the dimensions is multiplied by 5? The answer is 5 times bigger. The area would grow by 5 times. It would become 5 times bigger. And what do you think would happen to the area of the figure if one of the dimensions is multiplied by 10? I'm sure that you've already figured out it would be 10 times bigger. So now let's take a look at what happens when we change 2 of the dimensions. So the first thing we're asked is about doubling both dimensions, meaning we multiplied both dimensions by 2. Well, the dimensions or the area is now 4 times bigger. Take a look back at rectangle A and triangle B to see that this is true. And if we tripled both, we end up with 9 times bigger. And what do you think would happen to the area if both dimensions were quadrupled, meaning we multiplied both dimensions by 4? It would be 16 times bigger. And then, of course, it's going to ask, what do you think if one dimension is tripled and one dimension is quadrupled? Well, that would be 12 times bigger. The area would be 12 times larger. And what do you think would happen to the area of the figure if one dimension is multiplied by 5 and the other dimension is multiplied by 7? The area would be 35 times bigger. Hopefully you've caught on to the pattern and what this means, because now we're going to take this and apply it to circles, because circles are not polygons, because they are not made up of straight edges, so therefore they don't follow the same rules that polygons do. The first thing we're asked to do is to calculate the area of circle C. We should note that the area of circle C, fuzzy wuzzy was a bear, area of a circle is pi r squared. So we know we're going to say pi, which is 3.14, times they give us a radius of 2, and we know radius squared means radius times radius. So 3.14 times 2 squared, or times 2 times 2, is 12.56 centimeters squared. So we are asked to know what happens when to the area of if the radius of the circle is doubled, meaning the radius is now 4 instead of 2. So now we're multiplying 3.14 times 4 times 4. And we end up with 50.24 centimeters squared. And how does the new area compare to the original area? Well, if you were to take 50.24 and divide it by 12.56, you would get 4 times as big. And then you're asked, what would the area of the circle be if the radius of the circle is tripled, meaning the radius is now 6 instead of 2. So we're doing 3.14 times 6 times 6 to get 113.04 centimeters squared. And how does this new area of 113.04 centimeters squared compared to the original area of 12.56 centimeters squared? If we were to divide these, we would end up finding out that the area is 9 times larger when the radius is tripled. Now let's examine what this actually means and what happens and why. So what do you think would happen if to the area of the circle if the radius is tripled? We know that area of a circle is pi r squared, which means 3.14 times radius times radius. So if we are asked to triple both of the radii, we could expect that the area of the circle would be, the new area would be 9 times larger. And if we were to ask to make the radius 6 times larger, we could expect that the area of the circle would be 36 times larger. And if we were to ask to make the radius of the circle 13 times larger, we can anticipate that the area would be 169 times larger. And what do you think would happen to the area of the circle if the radius was multiplied by 5? If the radius is 5 times larger, we can anticipate that the area of the circle will be 25 times larger. And what would happen to the area of the circle if the radius is quadrupled? We could anticipate that the area would be 16 times larger. So now we're asked to take what we've just discovered to write a general rule describing how a polygon and how a circle changes if the dimensions are changed by a scale factor. So in order to figure out what happens when the polygon changes, hopefully you've noted that you can multiply the scale factors to find out how many times bigger the area will be. And for the circle, because the radius is being multiplied twice, you would need to multiply the scale factor twice to find out how much larger the new area will be. Now let's use this knowledge and this information to answer two problems involving area, and these are more higher level thinking application type problems. So, looking on, the local pizza shop has a medium pizza for $7.95 and a large pizza for $15.95. If the medium pizza has a diameter of 8 inches and the large pizza has a diameter of 16 inches, should you buy one large or two medium pizzas for your family? Then we are asked to explain our answer. Now, initially, everybody wants to say that you need two medium pizzas. And the reason you need two medium pizzas is because it's going to be cheaper and the diameter is going to be the same. Let's do the math to actually figure out if that's true. So if we're talking about the medium pizza, we know that the area of a circle is pi r squared. So we would say 3.14 times, if it's got a diameter of 8 inches, to find the radius we would have to divide by 2, meaning that the radius would be 4. So we do 3.14 times 4 times 4, because fuzzy wuzzy was a bear and area of a circle is pi r squared. And we get 50.24 inches squared for one pizza. But they're asking, should we buy two pizzas? So let's multiply that by 2 and get 100.48 inches squared. And we want to know how much money that's going to cost us. Well, we would have to take the cost of one pizza and multiply it by 2 and find out that we would get 100.48 inches squared for $15.90. So that's 5 cents cheaper. Now let's do the large pizza. For the large pizza, we would do 3.14 times a radius of 16 inches, or a diameter of 16 inches, means that we have to do 16 divided by 2 to get that our radius will be 8. So fuzzy wuzzy was a bear and area of a circle is pi r squared, so we multiply 3.14 times 8 times 8, giving us 200.96 inches squared for 15.95. So if you take a look at the area of the pizzas, we can get two medium pizzas for just over 100 square inches and 5 cents less, or we can get one large pizza for over 200 square inches for 5 cents more. Obviously, the large is the better buy because you get twice the pizza for 5 cents more. Now let's go on to the final one. The dining room table in Greg's house measures 90.3 centimeters by 75.8 centimeters. In order to be able to sit all his relatives, he has to add some leaves to the table. Okay, let's address what this means, because immediately students are thinking that he's adding like tree parts to the table. In a table, if this is my table, a leaf is a piece that you can add to it to make it longer. Okay, so when it says that he has to add some leaves to the table, he's not adding parts of the tree to the table or parts of plants. He's adding sections of the table to help make it longer. Because he's having more of his relatives out his house than normal, he needs a larger table. Now, the leaves measure 30.1 centimeters by 75.8 centimeters. And he adds 3 of them. We'll pretend they're all congruent. It then says, if he adds 3 to the table, what would this do to the dimensions of the original table? And then he also wants to know, what will this do to the area of the table? So if you take a look, he has not changed the length of his table, or he's not changed the width of his table. His table's just gotten longer. So what did it do? He has gone and he has doubled the length, because 30.1 times 3 is equal to 90.3. So he has effectively doubled the length of his table. And then you are asked, what does this mean? It means that the area is doubled. Because he only affected one dimension, he only has one scale factor to deal with.